Hi guys, this is Mrs. Villette, and this video is to address squeeze theorem problems where you may be multiplying by something that changes signs. So specifically, I'm talking about one of the problems that was assigned, limit as x goes to 0 of x times the sine of 1 over x. So the first thing you would want to do is just see if you can do direct substitution. So plugging 0 in for x is fine, the answer is 0. But plugging in 0 here into the sine function creates some issues because you are getting 1 over 0, which is undefined. So what I'm going to do is first recognize that direct substitution doesn't work. So kind of our options right now are direct substitution, or if we've got a 0 over 0 form, we can factor or rationalize. And then our last option is the squeeze theorem. So those are kind of our three main techniques. So direct substitution does not work here. We've already checked that. We don't have a 0 over 0 form, so we kind of have to go with the squeeze theorem. That's our last option here. So I'm going to focus in on the part of the problem that is allowing me not to do direct substitution. So sine of 1 over x I can't do direct substitution on. So I'm going to take just that piece out of the function and work with it. I know that the sine function, no matter what its argument is always bounded between -1 and 1. This particular function, sine of 1 over x, is that weird witch's broom function that does this, and then something like that. So no matter what, I can't plug in 0, but I know that everywhere else it's going to be bounded between -1 and 1. Now my temptation here is to try to build up what's missing, so to kind of zoom back out on this function and go, hey, I'm missing an x. So I want to multiply both sides by x. And you can do that, but it requires two inequalities to do so. So if you think about what y equals x looks like, y equals x is positive when x is positive, but it's negative when x is negative. So I actually get two different inequality statements. So I need one inequality statement that is valid if x is less than 0, and another one if x is greater than 0. So if my x is negative, that means when I multiply my inequality by it, it is going to be a negative quantity, and it should change the direction of my inequality. This is still going to be negative x, but now it's going to be greater than or equal to x sine of 1 over x, and greater than or equal to x. Now if my x is positive, I don't have to worry about anything. My inequality maintains its original direction, and I get negative x is less than or equal to x times the sine of 1 over x is less than or equal to x. Now I've got these two different inequalities that structurally have the same parts, negative x, x sine of 1 over x, and x, but the direction of the inequalities is different. This would matter if I were doing anything other than applying the limit as x approaches 0. But I am in fact applying the limit as x approaches 0. So I'm going to do this kind of lazily to all parts simultaneously. So on my leftmost part here, I can do direct substitution. So I go back up to my list. What can I do? Direct substitution, factor or rationalize, squeeze theorem. For this piece of the limit, I can do direct substitution. And I just substitute straight in. I get -0, which is 0. Is greater than or equal to the limit as x approaches 0 of x sine of 1 over x. Again, I don't know how to evaluate this limit. Is greater than or equal to 0. Same thing over here, but I get 0 is less than or equal to x times the sine of 1 over x. Oops, and I still need a limit there. Let me fix that. Is less than or equal to 0. So actually, I still need a limit statement in that middle one. Now in both of these cases, I end up with the same conclusion, which is that the limit as x approaches 0 of x times the sine of 1 over x is 0. So in essence, in this problem, because my outside limits were both 0, it didn't really matter that the direction of the inequality changed. So here it was greater than or equal to and greater than, and here it was less than and less than. I still come to the same conclusion. Now there is another way that you can do this. Okay, so the other way to do this is to use absolute values. So I'm going to look at this x times the sine of 1 over x graph, and I kind of have to look at the whole thing together. So I'm going to show you what the graph looks like. Okay, so here's what our graph looks like. I'm pretty zoomed in. And remember, the inequality that we were trying to use before was we were trying to use y equals x and y equals